Alrighty, here we go. Example number 4. We just have 4 and 5 left to do, so we're almost there, guys. Alright, so as always, start by finding your least common denominator. Our two binomials, those are already fully simplified. There's no factoring involved there, so think of that as one factor and that as one factor. This over here breaks down, but it breaks down very nicely. Just be careful. Looking for factors of positive 6 that add up to negative 5. So it's two negatives that multiply to 6 and add to negative 5. So it is, in fact, x minus 2 and x minus 3, which is beautiful because it matches up with the other two things that we already had. Thank goodness. Otherwise, this would have been a real bear of a problem. But just double check your factoring as you go. Make sure your signs make sense, okay? So our least common denominator, I'll write it over in the corner like I did on the last one. Here we go. Our least common denominator is equal to, from the first one we have x minus 3, from the second one we have x minus 2, and from the third one we have the same two factors. We don't need to duplicate because they didn't show up twice in the same denominator, okay? So that also means x is not allowed to equal positive 3 or positive 2 for final answers, okay? So hopefully you guys are getting really comfortable with that least common denominator part. If you're not, make sure you reach out to me and I'll walk you through some other examples at a slower pace so we can really go over that concept again. Okay, so now think about what are we going to multiply by to make this work. All right, so back over here, I need to figure out what am I going to multiply this by to get to x minus 3, x minus 2. So the x minus 3 is already there. I've got to multiply this guy by x minus 2. So that's going to give me 2 times x minus 2 from the numerator. This guy has the x minus 2, but it is missing the x minus 3. So I need to multiply by x minus 3. So I have plus 5 times the x minus 3. Okay? And that's going to be equal to, this was already the common denominator, so I just need that numerator written down, 7x minus 19. Okay? Again, we could be going through and writing. I'm going to write it and then I'm going to erase it. This is over x minus 3 times x minus 2. This is over x minus 2 times x minus 3. And this is over x minus 2 times x minus 3. All right? I haven't been writing the denominators now down because we talked about in the first example how once we have a common denominator, the denominators, since they're all the same, it's just the numerators that we need to make work, okay? So it's perfectly okay for you to never write the denominators down again. So you're going to see me get rid of this now, but that's what I keep talking about when I say they have the common denominator, so we're not going to bother writing it. Okay. So now we want to solve this equation. So distribute to get 2x minus 4 plus 5x minus 15 is equal to 7x minus 19. And then if I just combine like terms on the left, I've got 7x minus 19 is equal to 7x minus 19. And at this point, you should notice something. So take a minute, look at that. What do you notice? They're exactly the same. And what does that mean the solution is going to be? Well, I could get rid of the 7x's and then I have negative 19 equals negative 19. So that just means that this is going to work regardless of what x value I want. This equation has a solution of all real numbers. So remember our symbol for all real numbers is a capital R with an extra line. You could also write all real numbers. All right. But we know that this problem had domain restrictions, so that can't be our final answer. So the question then becomes, well, what is the final answer? Well, if we're supposed to have all real numbers, but we had two numbers that were restricted, our final answer is going to be this. We can say it is all real numbers except x equals 2 and 3. That's one way to say it. And that is a perfectly acceptable way to write it on a test or a quiz or whatever assessments we end up doing now. We could also write that with interval notation, saying it's everything from negative infinity to infinity except for the 2 and the 3. So quick refresher, that means we would have negative infinity up until 2, not including 2, so it's a parenthesis, union with from 2 to 3, union with, I'm out of space, so we're going to go down here and say it's from 3 to infinity. I'll be honest though, that's the more difficult way to write it. What I put in the box is totally and completely okay to write. So I would say just write that it's all real numbers except, instead of going through and saying the 3 separate intervals. But I'll leave it up to you as to which method you prefer. All right, so there is example number 4.